So now we've got 6 different examples of a non-homogeneous differential equation. And so really I just want to focus on identifying whether or not there is resonance between the forcing function and the homogeneous solution. So I've solved all the homogeneous part for each of these. So in question number 1, x double prime plus 2 plus 25x, this would be the homogeneous solution. And so now if I compare the homogeneous solution to what our particular solution might be, right? Our particular solution, here we've got x of p, would be a cosine 5t plus b sine of 5t. Both of those are resonant with the homogeneous solution right above. You can see they pretty much look exactly the same as the homogeneous solution. So this does have resonance. And in fact, our guess would be a times t cosine of 5t plus b times t times the sine of 5t. So we did have to include these extra t terms to get rid of that resonance. Okay, and then taking a look at question number 2, the left side is the same, so we still have the same homogeneous solution. On the right side, we've got an exponential here, so these terms are nothing at all alike. So this one does not have any resonance. So for this one, our guess could simply just be a e to the 5t, and we're not going to get 0 when I plug that into the left side of the differential equation. So with that guess, we should be able to figure out what a would be. In number 3, here we have a different homogeneous solution because the left side is different. And so here would be the homogeneous solution. And if I compare this to the forcing function over here, these are exponential. That's a trig function. So this one is going to not have any resonance. There's no issue with that. And our particular solution, therefore, would be a and cosine of 5t. And we'd also need to include the b times the sine of 5t. So that would be our particular solution guess to get that ball rolling in question number 3. Not an issue with resonance. In question number 4, here we've got the left side of this differential equation has homogeneous solution over here, and we can see that this term and this term, they're the same up to multiplication by a constant. So this one does have resonance, and therefore our guess, which initially might have been a e to the 5t. Well, if I were to try that one out and plug it into the differential equation, since it's a homogeneous solution, we would get 0. So that guess wouldn't work. So again, the way that we fix that is we multiply it by an extra power of t, and multiplying by that 1 power of t is sufficient. We no longer have any resonance with our homogeneous function over here. In question number 5, here the corresponding homogeneous solution for all of that is down below. So this characteristic equation must have had complex roots. And if I compare it to the forcing function above, here I can see that this is definitely going to have some resonance with that term below. They just differ by a constant multiple. So we're going to need to fix this issue with resonance. So there is resonance there. So our particular solution is going to be t times what our initial guess might have been. So we would have had some constant e to the minus t sine of 4t. We multiply that by a power of t, and then we also multiply the cosine piece. So that would be our particular solution. So one thing that's worth pointing out, our forcing function over here has resonance with this term over here, but we're going to multiply the extra t by both the cosine and the sine piece. So the t comes up over here and over there. So that one did have resonance. And in question number 6, here's our homogeneous solution. Here's the forcing function. The forcing function does not have any exponential piece, so there's no resonance with the piece over here. This has e to the minus t. This doesn't. So there's no resonance for this last one. This one does not have any resonance. And our guess would be a constant times the sine of 4t plus some other constant times the cosine of 4t, and we wouldn't need to multiply by any powers of t.